All right, so good morning. We're here. There's only 3 of us. With important information today, because I've mapped it out, and it looks like we'll be able to finish the fundamentals next week. Usually I would try to put the test before Thanksgiving, but it's going to have to be the week after Thanksgiving, and I'm sorry about that, but we need that week or next week to finish the fundamentals, and then we'll have test 1, which will be on the fundamentals. So, oops. Let's see here, make sure I'm recording. Test number 1. On October 15th. Week. Looks like a little, my double exclamation mark turned into a smiley face. Or like a freaked out smiley face, okay? So how it's gonna go is, before Thanksgiving, what I'll do is I'll post a practice test, okay? And then on October 13th, which is the Tuesday, so this is the Thursday. On October 13th, we'll go through that practice test together just to make sure, but it's a really good idea to have worked through that practice test before we go through it, because a lot of the time, if I say something, oh yeah, that makes sense, and then, because I've been there as a student, right, where I'm kind of like, oh yeah, well, no, that all makes sense, yep. And then I sit down and I try to do it myself, and it's just not working the same way. So it's a good idea to go through the practice test on your own, and then we will go through it, and then you'll be able to kind of pinpoint where you had troubles, and we'll go through it, and that's how you'll have the solutions to the practice test. So you won't have them until the review class. So I will post a practice test before Thanksgiving. Well, I guess it's capital T, isn't it? Maybe. No, it is. Before Thanksgiving, for you to try on your own. On October 13th, which is the Tuesday's class. So things got a little bumped around because I like to have the review the week before, so the Thursday for us, and then the test on the Tuesday. But anyways, this is how we have to do test 1. I'll aim for that for the next test, but we'll just have to make do. It is just the fundamentals. I don't want to say just, because there's a lot of stuff going on in there. But on October 13th, we will go through the practice test together. And I'll say this is how you will get the solutions. All right, so you do have to kind of hang tight, but you can always ask me if you're working on something and you're not sure before that class. Okay, so on the 13th, we'll go through the practice test together in a review class. Oops. Okay, so we'll do a review. Oops. So we'll do a review on the Tuesday after Thanksgiving, and then on the Thursday we've got our test. Okay. So that's good. Okay. Next week, oops. Next week, we will finish the fundamentals which will include inequalities and lines. So not just, well, drawing lines, that's part of it, but also what does it mean for two things or two lines to be perpendicular or parallel, right? So we'll talk about those. So that'll be the end of our fundamentals, and then we'll have the test after that. Just before, so because my other class finished a little bit early, so I'm hoping that it'll be the same for you guys, but we'll see. And because they were a little bit more ahead, but I had a little bit of time before class, so I posted the 1.3 homework. And then because I want to go through and make sure the questions are good for 1.4 and 1.5, but I'll post those as well. So I've posted the 1.3 assignment, and it is due October 9th, so that's the Friday, at 11:59 p.m. or 23:59, kind of makes it more clear. Okay, so it's due on next Friday at midnight, essentially, right? A minute before midnight. Otherwise it gets confusing. So good. Okay. Any questions about that? So I'll scroll up so you have almost everything. Okay. I don't see any questions. The review from last day, well, it was just this week, but it's not very long. It was more kind of complicated concept. So we skipped ahead into 1.5, and I introduced the quadratic formula to be able to factor a quadratic equation. So we talked about the quadratic formula to find solutions to quadratic equations which have the form ax squared plus bx plus c. And the quadratic formula is x, and this is one of those ones that you want to probably have on a cheat sheet somewhere. Oh, and I should say, so for the test, I am assuming that it's open book, but you definitely cannot be working with each other. So it's very easy to tell, for one, if people have been working together, but also just kind of, I'll know. So you have to work individually, but you will have all the resources available to you, right? You can pull up old assignments, you can pull up our notes, you can pull up the textbook if you wanted to, kind of hard to sift through. But even the practice test, right? I'm assuming that you'll have all these things available to you during the test. So when you're doing the practice test, get comfortable with using your resources, right? And figuring out where everything is. And kind of at the top of the list is the quadratic formula, which is negative b plus minus the square root of b squared minus 4ac all over 2a. Right? So then we use the solutions to factor a quadratic. And then we just went back into 1.4. So things got a little weird. I'll have to rearrange my notes a little bit, but that doesn't help you guys, sorry. But then we went back into 1.4 and we said, okay, well, a lot of these things will be easier now that we have the quadratic formula to draw from to be able to factor quadratic equations. Okay. So that's kind of the end of the review. So what we said was, okay, so that was in fundamentals part 3, the quadratic formula. And there's some stuff in there that we skipped that I plan on introducing as we go along. So that's why I want to pull those things out of the assignments for now, but that's for me, not for you to worry about. Okay, so in 1.4, right, we went through and we simplified these rational expressions. So we've got these algebraic expressions or rational expressions, which kind of look like this. So a rational expression is a fraction where the numerator and the denominator are both polynomials. So that's what we're dealing with here. And so now we're just trying to simplify rational expressions. And a lot of the time what we rely on is factoring, right? And so that's why I wanted to introduce that factoring trick before we go ahead and simplify. So we went through and we did 15, and we also went through and we did 18. So this is just simplifying. If we move on to multiplying or dividing rational expressions, well, if we're multiplying a rational expression, that's just, or two rational expressions, that's just a fraction times a fraction. We know how those behave. It's just a little bit trickier because A is a polynomial, C is a polynomial, right? So we have to expand this thing typically. Or if we're able to cancel some stuff, that would be great. Or we can divide rational expressions. So now I've got a fraction over a fraction, right? And so remember, any fraction over a fraction, we flip the denominator and we multiply, right? And so, and then we're able to simplify, right? We can probably cancel some stuff if we're able to factor enough. So that's where I want to jump in. And let's do, I had a good one highlighted here. Let's do 28 together. Just keeping in mind, we know how fractions behave. We've worked with fractions before, but they were just with numbers, right? And so now we've got these rational expressions that we want to multiply, and then we'll do one where we're dividing as well. Okay. Oops. So this is where we'll start today. Let's do 28 first. So looking here, just looking at this thing, it looks like I've got a quadratic equation over a quadratic. I think my go-to thing would be to rewrite these quadratics as if they're factored, right? And then hopefully, what I'm hoping for is that I'll be able to cancel a 3 plus x or maybe a 3 minus x or maybe even both, right? And so I'm hoping to factor these things and hopefully be able to combine or cancel. We'll see what happens here. So 28, I'll just write it out here. 28 is x squared plus 2x minus 3 over x squared minus 2x minus 3 times 3 minus x over 3 plus x. So what I'm going to do is I'm going to have a look at these. these are quadratic equations. So of course, it's going to be really useful to be able to recognize quadratic equations, right? But also, okay, we can factor these with the quadratic formula. So these are quadratic equations. So we can use the quadratic formula to factor each of these individually, right? So the numerator x squared plus 2x minus 3 is going to get factored, and x squared minus 2x minus 3 is also going to get factored individually. So let's see here. Let's deal with x squared plus 2x minus 3 first. If I rewrite this, right, ax squared plus bx plus c, then my a would be 1, my b would be 2, and my c, would be -3. So remember the flow that we go through, we find the solutions, which is we pretend that this is equal to 0, and we figure out, okay, what the solutions of this thing are, and then we use that to develop our factors. So we've got x is equal to, so these are the solutions for x is equal to negative b plus minus the square root of b squared minus, oh, I don't know why I said 2, 4ac, jumped ahead maybe, over 2a. So I get negative b, which is -2, plus minus 2 squared minus 4 times 1 times -3, all divided by 2 times 1. Okay. So now I've got -2 plus minus, and then 2 squared is 4. Right? I'll only keep writing these out and expanding these just for this one, and then I'll start just kind of combining all these under the square root, and then sometimes if it's an easy square root, I'll just take the square root. So if we end up at 25, for example, the square root of 25, I would just skip to 5, right? So we will start picking up the pace a little bit here, and so we've got 2 squared is 4, and then minus 4 times -3 puts us at plus 12 divided by 2. So this is going to be, give myself a little bit more space on the new page. This is going to be -2 plus minus the square root of 16, which I know is 4, right? Some of these squares we have on lockdown. So then I have -2 plus minus 4 over 2. So x is going to be -2 plus 4 over 2. And that -2 is one thing. And x is going to be -2 minus 4 over 2. So x is going to be -2 plus 4 is 2 over 2, which is 1. And another solution is that -2 minus 4, which is -6 divided by 2, which is -3. Okay. So now we use these solutions to make the factors. And hopefully this is familiar from last day, right? We did a lot of these. So now use these solutions to develop the factors. Right, where did we start? X squared plus 2x minus 3. X squared plus 2x minus 3 is going to be x minus 1 because I've got a positive here. So if I plug in x equals 1, then I need x minus 1 to be 0, right? So if this is a solution x equals 1, then x minus 1 would be one of the factors, times x plus 3. Same idea. If x equals minus 3 is a solution, then what we're looking for is for all of this to equal 0, right? So if x equals negative 3 is put in here, right, then I have negative 3 plus 3 is 0. 0 times anything is still 0, so it's a solution, right? And we can check this by expanding. Check the factoring by expanding. So I have x minus 1 times x plus 3. X times x is x squared. X times 3 is plus 3x. Negative 1 times x minus x. Negative 1 times 3 is negative 3, which is going to be x squared. 3x minus x is plus 2x minus 3, which is exactly what I wanted. Phew. Right? So now, in our original expression, right, we can replace the x squared plus 2x minus 3 with x minus 1 times x plus 3. So now we can write x squared plus 2x minus 3 over x squared minus 2x minus 3 times 3 minus x over 3 plus x. I can rewrite this numerator. That's the one that we dealt with up here. We're going to have to do the same thing for the denominator, but I just want to show you where we're at. So this becomes x minus 1 times x plus 3 divided by x squared minus 2x minus 3 times 3 minus x times 3 plus x. So now, factor, I'll just say this, okay? Looks promising because we're multiplying here and I've got a 3 plus x. And what's nice is I could rewrite this as x plus 3, right? X plus 3 and 3 plus x are the same. So I can cancel these, but I'm going to leave them there for a little bit longer. So I've got x squared minus 2x minus 3. So I'm going to pick up the pace a little bit here. And I'm going to use the quadratic formula to find the solutions and then have the factors. I'm just going to quickly double check my factors and then use them. So x squared is, so here we've got a is 1, b is negative 2, and c is negative 3. Negative b plus minus the square root of b squared minus 4ac over 2a. It might seem like a lot, but it is always a good idea to write out the blank formula that you're about to be using, right? More to show me that you know where things are supposed to be going, right? So if you started and just put the numbers in, right, but maybe you forgot the negative on the b, right, then I just assume that you did it wrong, instead of telling me, hey, here's the formula that I'm about to use, and then if that's wrong, then that's a smaller mistake in my mind, because, you know, just sloppy versus writing negative b and not putting in that negative 2 there, right? So you always want to show your work, and this is part of it where we write out the blank formula that I'm about to use. So this becomes negative 2 plus minus the square root of negative 2 squared minus 4 times a times negative 3. Looks kind of like the last one, right? slightly different. 2 times 1, which is going to be 2 plus minus, and so negative 2 is 4, or negative 2 squared is 4, minus 4 times negative 3, so plus 12 again, so I get the square root of 16. Here I'm going to skip ahead, so plus minus 4 over 2. So x is going to be, oops, not x. Well, x is x, but x is going to be 2 plus 4 over 2. And x is going to be 2 minus 4 over 2. So x is going to be 2 plus 4 is 6, divided by 2 is 3. And x is going to be 2 minus 4, which is negative 2, divided by 2, which is negative 1. Therefore, x squared minus 2x minus 3, if I have to factor this, x squared minus 2x minus 3, I can factor as x minus 3 times x plus 1. Right. I'm just going to check briefly by expanding to make sure that this equals the same thing. In fact, I'll just put it underneath here. X times x is x squared. X times 1 is plus x. Negative 3 times x is minus 3x. Negative 3 times 1 is negative 3. And so this becomes x squared. X minus 3x is negative 2x minus 3. Phew! Back to where we want it to be. So this is the factor that I'm going to replace this with in the denominator. So I'm going to go back here. And starting from here, right, now I can replace this x squared minus 2x minus 3 with the factor that we just found. In fact, I'm going to just steal this so I don't have to remember what it said. Paste. So now I've got x minus 1 times x plus 3 divided by, and now I'm replacing x squared minus 2x minus 3 down here with x minus 3 times x plus 1. Minus 3 times x plus 1 times 3 minus x over 3 plus x. Just checking in with yourself, right, before you go ahead and cancel this x plus 3 and 3 plus x, right, just tell yourself or remind yourself that a plus b is the same as b plus a. So I'm allowed to do that if I'm adding. Right, so here, what's nice is that this, and because I'm multiplying all the way across here, I'm allowed to cancel. X plus 3 is the same as 3 plus x. Okay. Before you get carried away, right, one thing to keep in mind is that 3 minus x is not the same as x minus 3, right? So 3 minus x is not the same as x minus 3. Note that 3 minus x is not the same as x minus 3. Okay. Just as try 3 minus 2. 3 minus 2 is 1, but 2 minus 3 is negative 1, right? So you just want to check in with yourself, just so you don't go ahead and cancel these because they actually don't cancel. So at the end of the day, what we're left with is x minus 1 times 3 minus x over x minus 3 times x plus 1. And that's it. That's it. There's a lot of factoring, right? but we're using that quadratic formula as a huge help now that we have it. So that's good. How about, I'll keep an eye out, I'm keeping an eye on the chat, but there's no questions coming in yet. So, but if you have a question, you can just ask it or you can throw it in the chat. How about we do 35? So here we multiplied these expressions and now we're gonna divide rational expressions. So 35. Whee. Awesome. So far, so good. Hey, that's great. So 35, we've got x to the 3 over x plus 1 all over x squared plus 2x plus 1. So I've got a fraction over a fraction, right? Just so I don't have to deal with a fraction over a fraction, what I'm going to do is I'm going to flip the denominator and multiply. Right? That way I can get them all on the same level. And then essentially I'm back to that previous question that we just did, right? Where we've got a fraction times a fraction. And then we're able to simplify, probably factor, and kind of go from there. So this is the same as x to the 3 over x plus 1 times, so now the denominator x over x squared plus 2x plus 1 gets flipped. So then I get x squared plus 2x plus 1 over x. So I'm just rewriting it as multiplication because that's our go-to if we're dividing fractions. Now, one thing that I see right away, because I'm multiplying this x to the 3 and this x, what I can do, or 1 over x technically, what I can do is I can cancel this x with one of these 3 x's, right? X to the power of 3 is x times x times x. I can cancel one of those x's and just be left with x squared. So this becomes squared and this goes away. Or if you prefer to deal with your exponent laws, it all goes back to exponent laws, right? But this x in the denominator could be brought up to the numerator and turned into x to the negative 1, x to the power of 3 times x to the negative 1, x to the power of 3 minus 1, x to the power of 2 is what results. So either way, we're using those exponents. So now I can rewrite x squared plus 2x plus 1. And remember that it's all over x plus 1 now. Because I'm multiplying here, I'm allowed to smush together the numerator, which is what I did here, and I'm allowed to smush together the denominator, which is what I did here. This x just turns to 1, right? And so x plus 1 times 1 is x plus 1. I don't need brackets around the x plus 1 because it's just on its own here. It's not being multiplied by anything, but it's nice to have them kind of lumped off. I do need the brackets here, right, because it's all being multiplied by x squared. What I'm seeing here is a quadratic, and if you look a little bit closer, right, you might see one of those special factoring formulas, right? And so if you go to your special factoring formulas, maybe they were in, now I can't remember where they were, part 1. Oh, maybe it wasn't 1.3. Anyways. Oh yeah, here, special factoring formulas, right? If we see something like a squared plus 2ab plus b squared, we can rewrite it as a plus b squared, right? Or a squared minus 2ab plus b squared is a minus b squared. So if we go back to what we're looking at here, we've got essentially a squared plus 2a plus 1 squared if we let b be 1, right? So we can start to recognize these, right? X squared plus 2x plus 1 is a special factor, right? Which is a squared plus 2ab plus b squared is a plus b squared. Where a is x and b is 1. If you don't see that this is a special factor, you can absolutely go ahead and just use the quadratic formula to find the factors, but sometimes it's a little bit easier to just be able to rewrite this as x squared plus 2x plus 1 equals x plus 1 all squared. So x squared plus 2x plus 1 is x plus 1 squared. I'm going to check it. X plus 1 times x plus 1, that's x plus 1 squared, is going to be x times x, which is x squared. X times 1 is plus x. 1 times x is plus x. 1 times 1 is plus 1. So I get x squared plus 2x plus 1, which is what I wanted. Also, the 2x, whenever I see a 2 times anything here, so usually if I see something like x squared plus 2x something, right? Even if this was 6, or not 6, but 18 would work, right? And so if I see an x squared and something that I could pull out a 2x here, I could try factoring, right? Or the special factor, right? So if we so usually if we see x squared plus 2x plus 1, then we just recognize that as a special factor, right? If you don't like these special factors, and I don't love special factors, I just plow through with the quadratic formula, right? And it will work out. You will get to x plus 1 squared. I don't. No one does. So, good. So just make sure once you've factored, right, that it expands to what you're looking for, and then you're able to replace them. Okay. So now we can replace x squared plus 2x plus 1 with x plus 1 squared. Okay. Let me see if I can copy. Clean this up a little bit. So I get x squared times x plus 1 squared over x plus 1. Yeah. No one likes the special factors, it turns out. And that's totally fine. You don't really need them. I think what you'll find is you'll start recognizing them eventually. So instead of trying to memorize them and trying to use them all the time, I think you'll start to pick up on where they pop up. And yeah, like I said, just use A as 1, B as 2, C as 1, and go through and use the quadratic formula. Totally fine. All right, so now I've got this way simplified thing that I'm looking at here. In fact, I've got x squared and then x plus 1 squared over x plus 1. So as long as I treat x plus 1 as one thing, then I'm able to cancel this square with this x plus 1 to the power of 1. So what I'm going to do here is this one goes away and this one cancels. And finally, I'm at x squared times x plus 1. And then I'm done. You could expand this out if you wanted to x to the 3 plus x squared. I'd say they're the same, so it doesn't matter. I'm going to leave it like that. Way simpler than what we started with, right? What we started with was this mess, right? And so then we were able to work and massage it until we got something very reasonable like this. Okay. Let's do 38, just because it's a little bit weird looking, and just so we've seen it. Looks way easier though. Weird for it to be the last one. X over y over z. Whee! Oh. X divided by y divided by z. As long as I remember that I can rewrite x as x over 1, right, as a fraction, then I'll be able to deal with this as a fraction over a fraction, which I can flip and multiply and simplify and be done. So what I'm going to have is I'm going to rewrite this as x over 1 times y over z. Flipped would be z over y. And now because I'm multiplying fractions, I've got x z divided by y times 1, but it just becomes y. Well, that's it. Good. Okay. So if we go back to where we were here, 1.4. And if we start talking about adding and subtracting rational expressions, the key here is that we have a common denominator. And there's a note here that we should use the least common denominator, but I'm going to go ahead and just use that common denominator that we developed before. So for example, even though we're dealing with these rational expressions, you can still find a common denominator the same way. You're just dealing with polynomials now. So for example, we'll start with 43, right? I've got a denominator of x plus 1 and a denominator of x plus 2, and I'm subtracting these fractions. These are not the common denominator, so I can't subtract them quite yet. I need to force a common denominator. And so here, hey, need all these. How do I? There, to zoom out. I'll say we can add and subtract rational expressions. We can add and subtract rational expressions by finding a common denominator. By finding a common denominator just like we did when we were adding and subtracting just regular fractions with regular fractions. Maybe I should put regular in quotes at regular fractions. 1 over 2 plus 3 over 5, you'd have to find that common denominator. And we've worked through those So now we're just kicking it up a notch here. So what that's going to look like, and I think we said, yeah, let's do 43. Looks nice. 43 is 3 over x plus 1 minus 1 over x plus 2. So I need to find that common denominator. And what I do is, on this first term, I glance over and I look at the denominator on this side here. So I multiply by x plus 2 over x plus 2. So that's my convenient value of 1. And then when I deal with the second term, I glance over at the denominator of the first term and I see an x plus 1. And so I multiply by x plus 1 over x plus 1. So then in both denominators, I'm going to have x plus 1 times x plus 2, right? And so I'm forcing that common denominator of x plus 1 times x plus 2. And then I can subtract my fractions. So let me just write this one out here. 3 over x plus 1 minus 1 over x plus 2 is going to be 3 over x plus 1, then to highlight, times x plus 2 over x plus 2, right? Glancing from here over here, x plus 2, and then minus 1 over x plus 2. In fact, maybe I'll put this x plus 1 in brackets too, just to show that they're individual things. Times, and then from this term I glance over to the x plus 1, and that's my convenient value of 1, times x plus 1 over x plus 1. Right? Now I have this common denominator of x plus 1 times x plus 2. So this becomes 3 times x plus 2, and I'll write out all the steps this time, and then later I'll just skip to the common denominator. But over x plus 1, oops, times x plus 2 minus x plus 1, oops. 1 times x plus 1 is just x plus 1, over x plus 1 times x plus 2. To simplify looking at this thing, I'm going to rearrange these, right? A times B is the same as B times A. So I'm going to rearrange these to be in the same order as here, just so I can see that now I have this common denominator. Common denominator is x plus 1 times x plus 2. So now I can combine these and I say 3 times x plus 2 minus x plus 1. Notice that I have to keep the x plus 1 inside the brackets, because if I bring in this negative only on the x, that's not true, right? I have to bring that negative onto the x and the 1, so that's why I'm keeping those in brackets just to be safe. All divided by x plus 1 times x plus 2. I'm going to carefully expand this and see if I can't simplify it a little bit more. So now I get 3x plus 6 minus x minus 1 over x plus 1 times x plus 2. Here's the deal. I'm not going to expand this until I'm really, really sure that I don't need it factored, right? Because we know that expanding is easy, factoring is a little bit harder. So whenever I have a factor like this, or something factored, I'm going to try to keep it factored for as long as I possibly can, just so I don't regret it later and have to refactor it, right? So I'm going to simplify the numerator and see if I can maybe cancel anything. 3x minus x puts me at 2x. 6 minus 1 puts me at plus 5. over x plus 1 times x plus 2. Looking here, some of the things I'm looking for are, could I pull out a common x plus 1 or a common x plus 2, right? Looking at 2x plus 5, it does not look like I can do that. And so, in fact, there's really nothing I can do about 2x plus 5. So I'm just going to leave it as it is. And this is the simplified version. Notice that I'm not expanding here. I'm going to keep it factored just to keep it nice and tidy. Okay. Good. So that was one with 2 terms, right? But if we go down here, right, some of these have 3 terms, and that's okay. We apply the same principle. Let's do 56, for example. (56) is x over x squared minus x minus 6 minus 1 over x plus 2 minus 2 over x minus 3. Okay. Clean this up a little bit. Minus 6. First thing, you absolutely could go ahead and just use all of these multiplied together as your common denominator. Okay? So you could take this term multiplied by x over 2 times x minus 3 over x plus 2 times x minus 3, right? And then just do that with all the terms. That seems a little bit tricky, right? Totally doable, but in this case, because I'm seeing an x squared minus x minus 6, I'm seeing this quadratic. I'm going to see if I can maybe factor it, and maybe, just maybe, I'll be able to pull out one of these terms and see what I can do. Try factoring to simplify the common denominator. So what I've got is I've got x squared minus x minus 6. Here, a is going to be 1, b is negative 1, and c is negative 6. X is negative b plus minus b squared minus 4ac over 2a. Right, you guys are going to get really good at the quadratic formula. And so we've got negative 1 plus minus the square root of negative 1 squared. You want to be really careful here. On your calculator, right, when you do negative 1 squared, the negative 1 is all in brackets. So if you just did negative 1 squared, it'll give you negative 1 likely. But a squared value will always be positive. So you just use that as a little check-in point and just say, oh no, I need to drop that negative. Oops. Minus 4 times 1 times negative 6 over 2 times 1. So negative 1 is 1 plus minus 1 squared is 1, minus 4 times minus 6 is plus 24. 1 plus 24 is 25. So I'm picking up the pace a little bit, divided by 2. I could even skip ahead to say the square root of 25 is 5. So then I've got 1 plus minus 5 over 2. So x is going to be 1 plus 5 over 2, which I'll put it on the same line here. 6 over 2 is 3. And x is going to be 1 minus 5 over 2. So 1 minus 5 is negative 4, divided by 2 puts me at negative 2. Therefore, what was the original? X squared minus x minus 6. X squared minus x minus 6 should be x minus 3 times x plus 2, right? Looking at my two solutions and essentially making sure that 3 minus 3 is 0 and negative 2 plus 2 is 0. We can expand it just to make sure. Check. Oh. X times x is x squared. X times 2 is plus 2x minus 3x minus 6, which is x squared. 2x minus 3x is minus x minus 6. Whee! What a thrill. So now what I'm going to do is I'm going to replace x squared minus x minus 6 with x minus 3 times x plus 2, just to see how sweet it is. Just to see what this thing looks like. So because I don't want to write it out again, I'll put it on a fresh page here. Maybe I'll scoot it over. Whee! So now I'm going to write x over x minus 3 times x plus 2 minus 1 over x plus 2. I'm going to write these x plus 2 and x minus 3 in brackets, right? And hey, look at how well this worked out. Not really a surprise, but pleasant nonetheless. 1 over x plus 2 minus 2 over x minus 3. Okay. So what I am looking at here, if I have to find a common denominator, which I do because these are subtracting, right? I've got x minus 3 here, and x plus 2 here and here. Well, x plus 2 times x minus 3 is going to be this one. So this one is what we're going to use as our common denominator. We can use this as our common denominator. Okay. Which means in order to get there, right, this term can stay as it is, but the 1 over x plus 2 has to get multiplied by x minus 3 over x minus 3 in order to have that same common denominator. Same thing with minus 2 over x minus 3 has to get multiplied by x plus 2 over x plus 2 to get that common denominator. So this becomes, maybe I'll give myself a little bit more room here. X over x minus 3 times x plus 2 minus 1 over x plus 2 times x minus 3 over x minus 3 minus 2 over x minus 3 times x plus 2 over x plus 2. Okay, slowly but surely I'm getting that common denominator, and then once I'm able to combine these, then I'm on easy street, right? So what I have is I have x times x minus 3 times x plus 2, and you could jump to the common denominator right away if you wanted to. That's totally fine, but we're just in our beginning stages here. So 1 times x minus 3 goes on top here. So then I have minus x minus 3 over, and what I'm going to do is I'm going to write all these in the same order, right? X plus 2 times x minus 3 is the same as x minus 3 times x plus 2. So I'm just going to reshuffle these so that they look the same, so I'm not confusing myself. minus 2 times x plus 2 times x minus 3 times x plus 2. Woo! Let's combine, let's smush together that numerator and put them over that common denominator. So I get x minus 3. Careful with that, the brackets here, right? I kept the brackets on the x minus 3 because it's actually minus 1 times x minus 3. So that negative is on the outside of both the x and the negative 3, right? So you don't want to expand those too quickly because you might forget something. Minus 2 times x plus 2 all over x minus 3 times x plus 2. Okay, nice. Home stretch here. I'm going to expand out the numerator and see if anything cancels out. Because there's just x's and constants here, I suspect that there will be some cancellations or maybe just simplification here. So I'm going to collect like terms and see what happens. X minus x plus 3 minus 2x minus 4 over x minus 3 times x plus 2. All right, so far so good. X minus x, well, those will go away. 3 minus 4 puts me at negative 1, and then minus 2x. But remember how we write polynomials? We usually write our highest power of x and then decreasing. So how I'm going to write this, and it doesn't matter, it just makes it look nicer. So I've got negative 2x, 3 minus 4 is minus 1. Right, just kind of switching up the order a little bit so I can have an x and then a constant instead of a constant and an x. Doesn't really matter, but I don't know, it's just nice. Over x minus 3 times x plus 2. Okay. One thing that I might want to do is maybe I'll pull out this negative, right? Just being careful when you pull out this negative, so when you factor out that negative 1 multiplier, then you get negative and then 2x plus 1 all in brackets, right? So you can do that. You can leave it like this, or you can write it as negative 2x plus 1 over x minus 3 times x plus 2. Either way is fine. I just want to do a quick scan here and make sure that I can't cancel with either of these in the denominator. 2x plus 1, there's no way I can rewrite it to cancel with either of these. So that's it. Lots of work, but it's all very similar, right? So we want to factor and we're simplifying. We're applying the rules we learned about fractions, right? How to multiply, divide, add, subtract fractions. Now we're just applying them to rational expressions. I know, you and me both. This is my second time today that I'm doing this lecture. My hand is like, ugh. But wait, there's more. Yeah. So, I know this one's like ultra writing. Anyways, let's see here. If we're talking about compound fractions, they're nothing new, right? It's just we've got some sort of like mix of fractions and non-fractions, but the trick is to just convert everything to a fraction, right? For example, if we're looking here, 1 plus 1 over x, I can convert that to one fraction by putting this over a common denominator and simplifying, right? So I'm going to work towards just making these fractions, right? Single fractions, and then I'm going to slowly kind of smush them all together and simplify either by multiplying or dividing fractions. And so as long as you kind of start from the sort of the bottom, I guess, like the nitty-grittiest fraction, and then just kind of work your way out. The example I want to do is 72 because it's got this multi-tiered thing going on. So compound fractions, we just apply the rules of fractions that we know. Right? Just once, I want to see if I can write next to it to try to save some space so I'm not scrolling so crazy. See how it goes. 1 plus 1 over 1 plus 1 over 1 plus x. Kind of need to see the screen for that one. What a mess, right? But what I'm going to do to simplify this whole thing, right, I'm going to break these down into a couple of different fractions, right? So I've got 1 plus a fraction, so I can combine these by finding a common denominator, and I can combine these to one fraction. So then I've got essentially a fraction over a fraction, right? Which I can simplify, and then I can rewrite 1 as a 1 over 1, right? The same thing as I did here to make it a fraction. So then I've got a fraction plus a fraction, which means I'm going to have to find a common denominator again for adding and subtracting, right? But so you kind of start here and you expand out until you've caught all these components. So here we go. This is going to be 1 plus 1 over 1 plus 1 over 1 plus x. This is technically 1 over 1, right? So here we're adding fractions. We're adding fractions. We know how to do that, so we can find a common denominator, right? Or we need to find a common denominator. Let's use 1 times 1 plus x. So over here on this 1, I'm going to multiply it by 1 plus x over 1 plus x. Right? 1 plus x over 1 plus x is 1. So if you wanted to jump straight to that, that's fine. Making sure that you write out all the other components that are just kind of being held steady so far, right? You don't want to skip around and drop those, because then the equality would not be true anymore. So then we've got 1 plus 1 over 1 times 1 plus x over 1 plus x plus 1 over 1 plus x. And I'll put those in brackets just to show that it's kind of one thing. This becomes 1 plus 1 over 1 plus x plus 1. Here I'm going to skip ahead a little bit, 1 plus x, and just go straight to that common denominator. Right? We've done enough of these that I feel like we should be comfortable going straight from here to here. Right? We can simplify this a little bit before we keep going. 1 plus, and then here I just want to make a note that we're going to start thinking about 1 as 1 over 1 to make it a fraction, to make it more obvious that it's a fraction. That's what we did up here as well, right? So not that wild. Over 1 plus x plus 1 is x plus 2 over 1 plus x. Focusing on this section here, I've got a fraction over a fraction that I can simplify, right? So this becomes 1 plus 1 over 1 times 1 plus x over x plus 2, which I'll put in brackets just to treat as one thing. Okay, this is good. So now I'm going to simplify this because I'm multiplying two fractions. Right? First fraction happens to be super easy, 1 over 1, right? And so here we've got 1 plus x over x plus 2, or 2 plus x if you want, but it doesn't matter. Why do you not simplify the 1 and 1 into 2? Oh, do you mean this 1 and 1? Yeah, so the problem is we can't simplify this 1 because it's essentially a fraction plus a fraction. So we're not ready to do that yet. So here, this is what it would look like, right? You'd have 1 plus a fraction. So we're going to rewrite this as 1 over 1. And now you're adding fractions, which again means you have to have that common denominator, right? So we want to keep track of when we first wrote this out, right? This 1 plus, and then the fraction was just this section. Okay, good. So that's going to be really important. And that's why I picked this one, to illustrate that we can't just smush them together. We have to kind of get at them as fractions. Good. So now I have to find a common denominator. I'm going to use 1 times x plus 2, right? Multiply 1 over 1 by x plus 2 over x plus 2. Puts me at 1 times x plus 2 over x plus 2 plus 1 plus x over x plus 2. Now I finally have this common denominator. So now I'm able to combine the numerator and say 1 times x plus 2. Now this one I will just kind of bust out the brackets. X plus 2 plus 1 plus x. There's no harm, right? Because it's just adding. So I don't have to worry about expanding that negative into the brackets over the common denominator of x plus 2. This I can simplify a little bit to x plus x is 2x, 2 plus 1 is 3. And so I get, and maybe what I'll do is, just to keep it on one page, move that up just one line, which puts me at 2x plus 3 over x plus 2. Having a look here, x plus 2, there's no way I can factor out an x plus 2 from 2x plus 3, which means I'm done. Good. Let me just make sure I'm doing everything that I set out to do in my side notes here. Good, everything looks good. So you can practice those compound fractions, just kind of making sure you treat them all as fractions, individual fractions, then everything should be good. So we're not going to do any calculus, it's pre-calculus, but I do want to introduce you to something called the difference quotient, which is something that looks like this. And there are a couple more on the next page, but we'll just go through one just because I want to introduce you to it. We're going to see more of the difference quotient when we develop it later on. But for now, we're just going to simplify this, right? And this looks a lot like what we were just doing. It looks like a compound fraction. And so here, I'm just going to copy this in and just keep in mind that there are a couple more examples in the notes there. We'll do 73. Now, what's fun about the difference quotient is that there's always going to be all over h in all of these, right? And so just the last few, I think, on the next page don't have it, but that's okay. They're a little bit different, right? So, but all the ones up to 76 have an h in the denominator. And what's nice is you'll know you've done it right if you're able to cancel the h from the denominator and you're able to kind of get rid of that h. Not all h's, but the h in the denominator should cancel away if you've done things correctly. So that's kind of nice to have like a little check-in point for these problems. So if we're simplifying this, right, we have to simplify something nasty like 1 over 1 plus x plus h minus 1 over 1 plus x all over h. Then we've got, well, let's write it out. 1 plus x plus h minus 1 over 1 plus x all over h. First things first, I'm subtracting two fractions here. So I'm going to simplify by getting them over a common denominator. The common denominator that I'm going to use is 1 plus x plus h times 1 plus x. And then we're going to remember that h can be rewritten as h over 1, which then I've got a fraction over a fraction, so I can flip and multiply and simplify that way, hopefully cancel some stuff. So here we go. This becomes 1 over 1 plus x plus h times 1 plus x over 1 plus x, right? Forcing that common denominator of the first denominator times the second denominator. And so from here, I glance over here, 1 plus x, and then from the second term, I glance over here, and that's my convenient value of 1. Hopefully that's really familiar by now. 1 over 1 plus x. I'm going to put brackets around these just so that they hang together. Times 1 plus x plus h over 1 plus x plus h. All over h. Kind of reminding myself that later I'll rewrite h as h over 1, just to emphasize that it's a fraction. But for now, I'm just finding these common denominators. So now what I get, I'm going to scoop my equal sign just over a little bit. Now I'm going to expand the numerator, or maybe I'll just write it out. 1 plus x minus 1, I can ditch that 1, because 1 times anything is just itself, minus 1 plus x plus h over 1 plus x plus h times 1 plus x, all over h. Notice that I extend this divisor a little bit further just to show that I've got a fraction over a fraction. So I'm just going to highlight that this is h over 1. 3 divided by 1 is 3, right? So h divided by 1 is h. So now I've got a fraction over a fraction. I could expand this. Maybe I'll do a little simultaneous work here, really kicking it up a notch. 1 plus x minus 1 minus x minus h over 1 plus x plus h times 1 plus x times 1 over h. All right, bringing that fraction from the denominator up to the top by flipping and multiplying. Okay, so having a look here, x minus x, 1 minus 1, so all of that will go away. 1 minus 1, it goes to 0. X minus x goes to 0. So what I'm left with is negative h. So I get negative h over 1 plus x plus h times 1 plus x. And what I'm going to do is I'm just going to put this h from here down here because I'm multiplying, so all this is times 1. Well, nothing's going to change up here if I'm just multiplying by 1. So what I'm going to do is I'm just going to smush this so it's one fraction. And now what I see is that this h and this h will cancel, leaving -1 up top. So now I'm so close. -1 over 1 plus x plus h times 1 plus x. Because this cancels with this. When you cancel h over h becomes 1, right? Not 0, so you want to be careful. Okay. Whew. Lots of ins and outs. Why can't we add h over h to 1 over 1 plus x? Now, where would that be? To get a common denominator. Do you mean up here? Okay, so the thing is, if we just add a plus h here, you can do that, but it's going to require a lot, like quite a bit more work. So that's why, I mean, for me, I think the easiest way to find the common denominator is just to squish these two together, right? And not try to figure out, okay, well, how can I factor this to pull out a common one of these, right? So because we can't just add plus h over h here, because then we would have to incorporate that into our common denominator as well, right? Yeah, so it actually ends up being way more work, and you just open yourself up to illegal math, right? Because if you end up adding h over h here, then you can multiply by 1, but you can't add 1 because that changes the value. So you could do that, but you're making your life a lot harder, right? So even though it looks nasty to use this times this as your common denominator, I'd say it's the safest way to go. Right. Good. So you can try it that other way, but I think you might be disappointed with how hard it becomes. Kind of a trap, yeah, exactly. All right. Oh yeah, so here's the end. Is that good? Cool. So there are a couple more of those to practice in the notes. Yeah, why are there only 4 people here? I don't know. There aren't that many registered in the course. So, but I mean, there should be more than 4 of us here. Or 4 of you. I mean, with me it's 5, but I don't really count. Yeah. Yeah, I don't know. Hopefully they're watching the videos later, but I don't know. If it was up to me, I'd rather watch them during class time because then it's like scheduled. Otherwise, watching 2 hours worth of video is really, really boring. Here it's like, yeah, exactly. Just get it over with. Oh yeah, all these fractions. Hey, we're heading into Halloween month. Fractions. Maybe I'll decorate my house with fractions. All right. So if we go into the notes, there are a couple of more of those to practice. Yeah, truly terrifying. Yeah, maybe I'll put this bad boy on here. Simplify. Right, so I'll leave these for you guys to practice, but I'll also post the solutions so that you have them. Same thing with these. These incorporate some of those exponent laws that we were working on before. So I'm going to leave these for you guys to work through because they are going to be a little bit trickier, right? But but I think they're good to practice, but I'm not going to emphasize them. So if they don't make sense, then don't worry about them quite yet. And we'll kind of pull them up as we need them. But what I do want to talk about and kind of finish with is rationalizing the denominator or the numerator. So we've seen rationalizing once before, but it was brief. So now what we mean by rationalizing is if we have a root, then if we want to rationalize something, it basically means get rid of the root. So if I have something like 1 over 5 minus root 3, and I'm asked to rationalize the denominator, what I'm going to do is I'm going to do everything I can to move this root 3, and I'll end up having to put a root in the numerator, but as long as I don't have a root in the denominator anymore, then I consider it rationalized, rationalizing the denominator. And then on the next page, we've got rationalizing the numerator, right? Get rid of this root in the numerator, which means I'm going to have to put it in the bottom, right, or in the denominator. So the trick with rationalizing in general is using what we call the conjugate radical. So if we have something like a plus b root c, the conjugate radical is a minus b root c. And what we'll see is c is once we multiply these out, we actually get rid of the roots, right? Now, this is hard to look at, right? A plus b root c times a minus b root c, that's yuck, right? But we'll start with 85, right? And just have a look at how it behaves. And then you'll see it's not so bad. But first, let me make a little note. When we are asked to rationalize the denominator or the numerator, when we are asked to rationalize, often we're rationalizing the denominator, so that's why we're doing that one first, but we can rationalize the numerator too. So when we're asked to rationalize the denominator, I'll put in brackets or numerator, we multiply by the conjugate radical, to, and I kind of think of it as moving the square root. So to move the square root from the denominator to the numerator, and then I'll put it in brackets or vice versa for the numerator if we're rationalizing the numerator to the numerator or vice versa, right, depending on what we're doing. The conjugate radical of a plus b root c, oops, is a minus b root c. Okay. For example, if we have oops, why? Hey. 4 plus 2 root 3, right? The conjugate is 4 minus 2 root 3. Right? So really the only thing, so looking at these ABCs is kind of nasty, but the only thing that we're changing here is if we have a plus, we have to put a minus, and if we have a minus, we have to put a plus. So, or if we have 3 minus 2 root 6, then the conjugate would be 3 plus 2 root 6. So let's have a look at, let's do the first one maybe, right? And see how these things are going to behave, and then we'll do the example. So if we have 4 plus 2 root 3, because it's nice to have just numbers, 4 minus 2 root 3. Now I'm expanding this to see if I can get rid of these roots, which I should be able to do because I'm multiplying by the conjugate. So I've got 4 times 4 is 16, and then 4 times negative 2 root 3. So I'm just going to do plus 4 times negative 2 root 3. I'm just going to keep it like that for a little bit until I can kind of sort things out here. And then maybe I'll move this over, give myself a little bit more room. Plus 2 root 3 times 4, and then plus 2 root 3 times negative 2 root 3. Notice that I'm keeping all these just for a little bit longer, just to show what's going on here. But in the end, you'll see that the roots drop out. So now I've got 16, and then 4 times 2 is minus 8 root 3. So I've got 16 minus 8 root 3, and then 2 times 4 is plus 8 root 3. 2 times negative 2 is minus 4, and then root 3 times root 3. Root 3 times root 3, if you think about converting the root to an exponent of 1/2, then I've got 3 to the 1/2 times 3 to the 1/2, 3 to the 1/2 plus 1/2, 3 to the 1, the roots go away. Yee. So here, right, root 3 times root 3 is just 3. And negative 8 root 3 plus 8 root 3 equals 0. So what I'm left with is 16 minus 0, or maybe plus 0, minus 4 times 3. Yeah, so roots just undo the squares, and square roots undo squares. Exactly. So they're like multiplying division. Exactly. Nice. So now I have 16 minus 12. After all that, yeah, exactly. If you cube a cube root, then you're undoing that, that root, and you're just left with whatever's inside. So all of this womp womp turns into 4, but we have gotten rid of those nasty roots. So, and that was the whole goal. Okay. So let's have a look at an example. Let's do one of these. Maybe, should we do 86? I don't know. Doesn't really matter. Let's do it. So if we've got 86, 3 over 2 minus root 5, if I'm asked to rationalize the denominator, what I'm looking for here is, well, okay, I need to get rid of this root. And then I think, okay, well, I need to multiply by the conjugate, because that's what we just saw here, is that's how we're going to get rid of that root. So if we have to multiply the denominator by the conjugate, we also have to multiply the numerator by the conjugate, and that's what I mean by we kind of move that root upstairs to the numerator. So this becomes 3 over 2 minus root 5 times 2 plus root 5 over 2 plus root 5. I'm going to throw some brackets around there. There too. Right. This is the conjugate of 2 minus root 5. So it's going to make the denominator look really nice because it's going to get rid of that root, but this root 5 is going to stick around in the numerator, and that's okay. So this becomes 3 times 2 is 6 plus 3 root 5. Fine. 2 times 2 is 4. 2 times root 5, so plus 2 root 5. And then negative 5 times 2 minus 2 root 5. Of course, those are going to go away. Minus root 5 times root 5 puts me at 6 plus 3 root 5. We'll cancel these. Bing, bing. Oh yeah, so why do they change signs here? So do you mean this one, this plus from the minus? Yeah, so that is, so this is the trick that we use. So you look at this one here, and then it's called the conjugate when you switch the sign from negative to positive, or if you have a plus here, you would have minus here. And then what you'll see is once you multiply these out, then the roots are going to go away. And so you look here, you basically write out the exact same thing, but just switch the sign over here, right? And then use this as your value of 1. So awesome. So now I've got 6 plus 3 root 5 over 4 minus root 5 times root 5 is 5. 4 minus 5. So what I'm left with is 6 plus 3 root 5 over negative 1. But to make that look a little bit nicer, I'm just going to bring that negative upstairs. Right, 6 plus 3 root 5 over 1 is just 6 plus 3 root 5, but I'm going to have that negative on the outside of all of that. So what I'm going to end up with is negative 6 plus 3 root 5. If you want to, you can bring that negative inside. I'm going to leave it on the outside. Good. Let's do one where we have to rationalize the numerator. You'll see it's the same thing. We're just trying to get rid of the root in the numerator this time. Right? Up here, we were able to get rid of the root in the denominator. In fact, we don't have a denominator anymore, and that's good. That's easy. Right? We had to move the root somewhere, and it goes upstairs. Here, when we rationalize the numerator, now the root is going to be upstairs in the numerator, and we're going to have to move it downstairs, but we don't want any roots up top. I like the root r plus root 2. It's nice to see something that's not using x's necessarily. Right? So let's do 93. I've got root r plus root 2 over 5. I need to rationalize the numerator, which means I need to get rid of all those roots in the numerator. So what I'm going to do is I'm going to have a look at this, and I'm going to figure out what the conjugate would be. The conjugate is just, right, we're swapping the sign here. Root 3 or root r minus root 2 would be our conjugate. So let's start there. Root r plus root 2 all over 5 times the conjugate of root r minus root 2 over root r minus root 2. And they'll throw these in brackets just to show that these are kind of their own things. Okay. I'll start expanding these. If I come into, if I run into more roots, right, then I might have to rationalize again. But let's see what happens here. So root r times root r, we know is just r. So I'm gonna skip some of those steps now, right? And if you wanna do the same, right, root r times root r is just r. Minus root r root 2 plus, and I'm going to write them in the same order, plus root r root 2, and then root 2 times negative root 2 is negative 2. Over 5 times root r minus root 2. Minus root r root 2 plus root r root 2 is going to go away. I can expand this a little bit if I want to. You can leave it as it is too if you want. But I'll have r minus 2 over 5 minus root r minus root 2. And then I'm done. Right? No more roots in the denominator, or sorry, in the numerator. So use the same denominator, which was the goal. We had to move them downstairs, but they're gone. All right. So I'll keep an eye out for some questions in there, but until I see any, I'll just go to the very end of these notes here because we are at the end. Oh, all our hands are all cramped up. I just like to include this little blurb here. So there are some common mistakes that we make, right? And so you want to go through and just kind of highlight these things that you don't want to do, right? And sometimes, I mean, that can kind of throw you for a loop, but just making sure that after this section, you're not doing a plus b squared. You can't bring that square in unless you're multiplying or dividing inside, right? So if you're adding, you can't split that square across the terms. Same thing with the roots. If you're adding or subtracting inside there, same thing, unless you have a common denominator, you can't combine the fractions, right? We can't cancel just one term because both a and b are being divided by a, so we can't cancel that way. So just kind of a list of really, really common errors that people make. So just go through and kind of practice those and make sure that you're not making those same mistakes. Okay. All right. So, but I'll leave those in the notes there. So that's the end of 1.4, but then we also did 1.5 this week with the quadratic formula. So I'll post assignments for those two in a little bit today. And then the test is on October 15th. So I'll scroll to the top of our notes here, right, which is the Thursday. Okay. But yeah, next week we're going to do inequalities and lines, and then we'll be done our fundamentals, and that will be for our test 1. Any other questions? Well, thanks to you for showing up. And I hope you have a very nice weekend.